This is The New J.O. by Emily Wiley and Jasjeet Sandhu. On these two slides, you will see the views of our model. We have the bird's eye view, north view, west view, south view, and east view. Our school is designed to hold around 1,300 students. We have an elevator that goes from the first floor to the second floor for students who cannot take the stairs. We also have a staff parking lot to accommodate staff who need to drive to school, and undercover bike racks for both staff and students who bike to school. We have implemented universal gender washrooms for students who do not feel comfortable in either the male or female washrooms. And finally, our cafeteria offers a variety of meals for students with dietary and health restrictions. The school grounds consists of a staff parking lot, bike racks, a courtyard with picnic tables and benches for students to eat or study on dry days, a grass field for PE classes and outdoor sports, an outdoor classroom for outdoor education, and a separate gymnasium.
On the first floor of our building, the main entrance leads into a large foyer, where the main locker area would be located. The indoor-outdoor green space is in the middle, surrounded by the staff room, an exceptional students' room, the counseling suite, office, and elective classrooms. All of these classrooms have windows that overlook the green space for natural light to enter and a nice view. All along the sides of the walls, there are the shop's classes such as woodwork and metalwork, as well as the drama studio. The geothermal heat pump is also located on the side of the building. On the opposite side, there are more classrooms, a computer lab, and an athletics room. On the side of the building opposite to the foyer, there is a large cafeteria that also contains a school store, as well as classrooms where foods or cafeteria service classes take place. There are 2 staircases leading up to the second floor, as well as an elevator for accessibility. Throughout both the first and second floors, there are staff, student, and gender-neutral bathrooms. The second floor of our building contains classrooms such as English, social studies, science, and math. Our library is also located on this floor, along with a research lab and rooftop garden, where produce grown here will be used in the cafeteria. There is a balcony in the middle overlooking the green space below, on the first floor.
Our large detached gym has locker rooms, safe pullout and permanent bleachers, a dividing wall for PE classes, a volleyball court, basketball court, and it also functions as the school's auditorium. For assemblies, the gym can hold all staff and students in the school. The walls are soundproofed and there is a built-in sound system. There are also blackout blinds that cover the windows, a projector and screen that come down from the ceiling for presentations and assemblies.
In the middle of our building on the first floor, there's an indoor-outdoor space, which is designed to be a peaceful place where students can study, eat, take a much-needed break, and refresh. On the roof of the school, there is also a dome-shaped skylight roof with double glazing, which contributes to the green space. The double glazing layers on the skylight is a way of reducing the heat that enters the building.
As we know, because of our geographic location on the Cascadia subduction zone, we are at risk of a megathrust earthquake at any time. Because of this risk, our school is built to combat seismic effects in the event of an earthquake. Our school is constructed with steel reinforced concrete and steel framing. Steel increases the ductility of the building, increasing the flexibility of it so it doesn't snap or crack when an earthquake hits. Seismic tremors at the base of buildings is what cause the most damage to rigid structures in dense soils. The foundation is built in a way to reduce the friction between the soil and the base of the foundation to prevent the effects of horizontal seismic tremors. This was done by leaving an air gap between the soil and the foundation to keep the building from crumbling. Additionally, transverse and longitudinal beams support the foundation and add stability. This diagram shows the base and foundation of the building. Number 1 is a wall panel. Number 2, the transverse and longitudinal beams of the foundation. Number 3 is a solid reinforced concrete foundation slab. And number 4 is an intermediate sandy cushion. The roof of the gym is a curved shape which has steel lattice support framing. The crisscross shape of the lattice framing increases the strength of the roof, and if one piece breaks, it is unlikely for the rest to crumble with it. The gym is an ideal place for post-emergency meetings. After some research, we found that the building we learn in has an effect on our ability to learn and our mental health. We focus the aesthetic on our school to feel the least like a concrete box as possible. We have high ceilings, lots of windows that allow tons of natural light in, and light-colored walls. Research carried out by the University of British Columbia concluded that the visual presence of wood inside of buildings helps reduce stress levels among its occupants, so we decided to use wood in our interior. We used wood on the walls as accents, beams for stability, and for its versatility. Wood can also improve the air quality of a room by moderating the humidity. Proper insulation is important for keeping warm air in and cold weather out, so our insulation is called extruded polystyrene. This insulation has excellent water resistance and is capable of withstanding extreme temperature changes. Each classroom is also soundproofed, so students can focus without hearing yelling from other classes or from people in the hallways. In our school, we wanted to do as much as we can to reduce our waste and properly dispose of the waste we do create. We do this by having a better waste sorting system with easy-to-understand bins that sort green garbage, plastics, aluminum, and regular garbage. The green garbage will be used in our composts in our garden to be made into dirt and fertilizer. Insulation is partially made from post-consumer plastics and can be recycled if it ever needs to be replaced. Energy conservation is important, so to save energy from heating, we have our insulation, which helps keep temperatures constant in the school to reduce the need for heating and cooling. And we also save energy on lighting. First, we use energy-efficient lighting such as LED lights, which use much less energy when compared to the lighting that our school currently uses. Secondly, our school has lots of windows that let in natural light in pretty much every room in the school. When there is natural light, the lights don't need to be turned on, which saves energy. Our windows also use smart technology and can be tinted with a press of a button. In the summer, the window tint will reduce the heat trapped by the sun inside of the school. All of the features in our school are designed to stay working for a long period of time, which reduces the waste from replacements and repairs. To provide us accessibility for staff and students who bike to school, we have an undercover bike rack. And on our school grounds, we have plants, trees, and other greenery around the school to absorb some carbon dioxide and for added aesthetic benefits.
To tackle local climate concerns such as rain, heat, and the cold, our school consists of various designs and systems. For rain, our school has a slanted roof so the rain doesn't pool on the top of the building, rather flows down pipes and into drains on the ground. For heating or cooling, our school has a geothermal closed-loop vertical system, which works by moving temperature-conducting fluid through an underground loop of pipes beneath or near the building. Heat is then circulated back into the pipe and distributed throughout the building using ductwork. Cooling works in a similar way. As air is circulated through the building, the heat pump removes heat from the air and transfers it to the fluid that circulates to the ground. Since the ground is at a lower temperature, heat dissipates from the fluid to the ground. The experience of cold air blowing into the building is the result of the process of removing heat from the circulated air, transferring the heat to the ground, and returning cool air back to the building. Geothermal heat pumps are able to switch between heating and cooling. Therefore, the heating and cooling of our school will be done by the same system. The energy resources we will be using in our school consist of the geothermal heating and cooling systems, as well as solar panels. The geothermal heat pumps, as mentioned before, will be able to provide heating to the school in the winter and air conditioning in the summer. This will reduce our electricity use, comparing it to the standard heating or air conditioning systems. Geothermal heat pumps are also beneficial in the aspect that they require minimum maintenance and have a long lifespan. We also have solar panels on the roof of our school, which will help reduce our carbon emissions.